As I said, a general trend in skull evolution is the loss of bones. In mammals, dermal bones are not the only ones that have reduced in number. Chondrocranial elements also tend to reduce in number by fusion, creating composite bones. Whereas there were three occipital bones in reptiles, the supraoccipital, exoccipital, and basi-occipital, mammals only have one fused occipital bone at the backside of the skull. That's named occipital bone. There are as many as three sphenoid bones in mammals. These are the basisphenoid, the presphenoid, and the orbitosphenoids. The alisphenoid, although it has a sphenoid in its name, is actually derived from one of the gill arches, so it's not technically part of the chondrocranium. In the cat skull, you'll see these sphenoid bones forming the floor of the cranial cavity. In humans, these have already fused into a butterfly-shaped sphenoid bone where the brain sits. Another example of a composite bone is the temporal bone on the sides of your head. The temporal bone partly forms the zygomatic arch, this one, the cheekbone. It receives some, or actually multiple, contributions from all three components of the vertebrate skull, the chondro, dermato, and splanchnocrinium. Broadly, the temporal bone has a squamous portion, a tympanic portion, and a petrous portion. The squamous portion is that broad, flat plate on the side of your skull. It is homologous to the squamosal bone of other tetrapods. The squamous portion forms partly the zygomatic arch. The tympanic portion houses the middle ear cavity and bears the external ear canal. In some species, like the cat, it forms a visible bulge called the tympanic bulla. The petrous portion consists of fused otic bones, now called petrosal bone, which houses the inner ear cavity, where the sensory hair cells and vestibular systems are located. The petrosal bone is only visible in the sagittal section of a skull because it's located interior, and sometimes the petrosal bone has an externally visible mastoid process, which you can feel as that bony process below your ears. So this is the petrosal bone plus its mastoid process is sometimes called as the petromastoid bone. Lastly, the three smallest bones in the body are located in the middle ear cavity. In elementary, you probably knew them as the hammer, the anvil, and the stirrup. Synonyms in comparative anatomy are the malleus, the incus, and the stapes, respectively. These three middle ear ossicles greatly improve the range of sound waves that our mammalian ancestors could hear. Reptiles, birds, and amphibians only inherited the stapes bone. The middle ear ossicles, together with the styloid process, are derivatives of the gill arches. So we'll come back to them in the splanchnocrinium portion. Here's a visual summary of the multiple phylogenetic origins of the mammalian temporal bone. The squamous portion came from the squamosal bone, and then the petrous portion, or the petrosal bone, came from the otic bones. The tympanic portion partly came from the mandibular series of dermal bones, specifically the angular, and the middle ear ossicles, together with the styloid process, came from the gill arches. The palate of vertebrates form the roof of the mouth cavity. Primitively, there's only the primary palate formed by the palatal series of dermal bones, as shown by this palatal view of a primitive tetrapod skull. Note that with only the primary palate, The internal nares opens near the tip of the mouth. That's where the air will come out, coming from the external nares. A secondary palate evolved in some lineages of tetrapods, and this is a bony shelf made by the midventral projections of the premaxilla, maxilla, and palatine bones. Note that the formation of a secondary palate shoved the position of the internal nares more posteriorly, nearer the throat, and this creates a separation between the nasal cavity inside and the oral cavity here, separating basically the air and food passageways. The secondary palate evolved in sea turtles, crocodilians, and mammals. In mammals, the secondary palate is composed of the premaxilla, maxilla, and palatine bones, which forms the hard palate, that bony portion of the palate. And this is continued more posteriorly by the fleshy portion called the soft palate. Again, the internal nares, by the formation of the secondary palate, is moved more posteriorly than its original position. And therefore, the air and food passageways are separated. This separation allows you to chew or masticate properly without interfering with the airflow. The hard palate also helps in building up a negative pressure inside the oral cavity for suckling newborns. Fishes, with the exception of lungfishes, don't have an internal nares. So you can see here that the external nostrils, external nares, simply pass through the nasal sac or olfactory sac for smelling, but it doesn't open up into the pharynx, as in the case of tetrapods and lungfishes, via the internal nares.